Hello everybody, welcome to this new module testing and validation. And the first lesson in this chapter or module is how OEMs automate validation across vehicle platforms. Understand this sentence very carefully. How OEMs automate or how OEMs streamline or standardize validation across various platforms. Now, explain in detail how OEMs automate validation across vehicle platforms. OEMs are automating validation across vehicle platforms to handle the growing complexity of software-defined vehicles, meet tighter development timelines. I'll take a pointer, meet tighter development timelines, and ensure consistent quality across diverse models. Okay, so and now as competition is growing harsher and harsher, the time required or time set by OEMs to develop a software defined vehicle is becoming shorter and shorter. So naturally, to ensure consistent quality, a standardized automation or standardized validation is required. Now, why is automation so essential? Modern vehicles integrate multiple domains, ADAS, infotainment, powertrain, connectivity, each with its own ECUs and software stacks. Now, when it comes to manual validation is no longer scalable. Automation helps OEMs reduce Automation helps OEMs to reduce the time to market, improve test coverage, minimize human error, enable continuous integration and delivery. Understand this very carefully. To enable the continuous integration and delivery, because this is one step which may usually take a lot of time if automation is not done properly. Now coming to the key strategies for automated validation, virtual ECUs. Okay, the first important strategy is through virtual ECUs. Now OEMs simulate ECUs before virtual hardware is available and enables early software development and system level validation. Okay, now it supports fault injection, debugging and traceability. Now, when it comes to shift left validation, moves testing earlier in development cycle, using virtual platforms and cloud native environments to validate architecture and integration before hardware arrives, and reduces start of production delays by identifying issues early. So these are all the various strategies. One is virtual ECU and next is the shift left validation. And to proceed further, integrated hardware in loop systems. All right. So actually, I myself have prepared one training program in Udemy where I'm covering all the various types of hardware in loop systems. You are most welcome to check that particular video. Okay, if you go to Udemy and check Palem Vamsi, you will definitely see one training program with about all the in loop testing programs in automotive industry. Now coming back to this integrated hardware in loop system, multi-domain hill setups replicate real world scenarios, test interdependencies across ADAS, test infotainment, powertrain and connectivity, accelerates development by enabling parallel testing, AI driven testing, uses machine learning to generate test cases and predict system behavior. Now enhances coverage of edge cases and complex interactions. All right, so this is the main advantage of AI driven testing. It enhances the coverage of edge cases and complex interactions. Edge cases means testing as near to the ECU as possible. Now reduces the engineering cost and effort. And now when it comes to cloud based validation testing or platforms, it has a big advantage of centralized infrastructure for simulation, data analysis and collaboration. All right, now also it enables remote testing, real-time feedback loops, scales easily across global teams and vehicle platforms. Okay, now in this table I request all of you to pause the video and see this table very carefully. Now these in this table tabular form, I am talking about the technique, the purpose and the example. Okay, when it comes to software in loop, the purpose is virtual testing of the embedded code. Okay, and example is validating UDS service logic. Next is model in loop, algorithm validation, engine control modules. The purpose is algorithm validation and example is engine control models. Next is technique, end of the line testing, final checks before delivery, OBD readiness and DTC clearing. And when it comes to regression testing, ensures updates don't break existing features. Okay, so ensures updates don't break existing features and ECU firmware updates. So these are the various kind of validation techniques used. Now, when it comes to a real world example, let me give you a small real world example. Tata Technologies and Emerson accelerated EV powertrain validation for European luxury OEM by developing test rigs in just 5 months and a 60% 7% improvement over traditional timelines. Okay. So this European luxury OEM by developing test rigs in just 5 months, a 67% improvement over traditional timelines. Now, when in future there are further virtual testing concepts like digital twins, where real-time replicas of vehicle systems for continuous validation, autonomous test benches, which include self-learning systems that adapt to a new software releases, regulatory integration, automated compliance checks for ISO 26262, ISO STG 21434, UNECE WP29. So these are the various regulations that need to be adhered to, and these are the various regulations against which validation is carried out before they are approved. Thank you.